Welcome back, everybody. So in the last video, we worked on creating a simple 2D camera and looked into orthographic projections a little bit, and this is where we are. So we just built it real quick. So basically we're just parsing the UVs from the tile set there and getting this little eye. So now the goal for today, to actually make a shader class and a shader loader. So the first thing we're going to want to do today is create a new project for our new rendering code. I'm going to call it Scion rendering, and if we just go here, we've done this before, so go up, go add, new project, and we're just going to do an empty project, empty C++, and we're going to call it Scion rendering. Cool. Create. Alright, now that that's created, first thing we're going to do with this one is go to our properties, and we're going to change this to, we want this to be a static lib, and we're going to change the C++ language standard to C++ 20, apply. Okay, we also want to get the reference to soil and glad, so we have that there, and we're also going to want to add in our VCC or VC++ directories, and one of them will be soil. And we want to use solution dir or solution directory. Cool. Add another one. Glad. Whoops. Let's fix that. That should be that. Same with this. All right. And we also want GLM. So we go to Scion, dependencies, GLM. All right, so now that the project's created, we have our dependencies set. We're going to want to create 4 new folders. So go here, go to add new folder, and we'll call the first one rendering. And then inside of this, we're going to have 3 folders. And it's going to be essentials, core, and one more for buffers. We're not worried about the core and the buffers today, so today we're actually just going to be working on the shader. So we're just going to add in our essentials, and that's going to be new shader.h. So a few things we're going to need. We're going to need a string, include string, and then we need an unordered map. Then we also need glad, so include glad, and then include GLM. And then we're going to have our namespace, Scion rendering, and our class shader. So what are we going to need? We're going to have private, we're going to have public. Okay. So in the private, we're going to have GL uint and shader program ID. Oops. And then we're going to have a string for both the vertex path and the fragment path. It's also a good practice to have the locations for the uniforms cached into memory. If we already have the location of the uniform, we can skip the query to OpenGL. So it's a good idea to make a map. So we'll do that. Unordered map, std string, and that'll just be gl uint, and we'll call this uniform location map. Oops. We can also create a small private function to see if we have already put the uniform into the location cache. So we just go gl uint get uniform location const std string reference uniform name. Cool. Now we can create our constructor and destructor. So shader gl uint program const std string vertex path and const std string fragment path, our destructor. We need to create some getters and setters to set uniforms and whatever. So first thing we're only gonna set 2 right now because I think we only need 2. Is first is going to be set the uniform int. And that's going to be the name of the uniform and the value. And then the other one we need for today is the set uniform mat 4 because we need that for our camera. So void set uniform mat 4 const std string reference name glm mat 4, and we'll just call that mat. Those are the 2 we need today. So we can to-do add more setters as needed. I'll leave those to you as an exercise. Same with the getters. We don't need the getters right now, but you should do the getters. So to-do add the getters for the uniforms. But I'll leave that as an exercise for you. And next video, they should already be filled out. Why don't you try to do it yourself? We're also going to need to have a way to enable and disable the shaders. So we'll add those functions. So we'll just call void enable, void disable. And then we can have one more just to get the shader program. Shader program ID. And then we're just going to return shader program ID. All right, so now we can just highlight these. Go down to create. So you hit control period, go down to create declaration definition. It should make those all for us. Cool. Made that. Go here. Now I don't actually like when it does this, so I'm actually just going to do this and go control H, and then we want to replace Scion rendering. I want to replace that with nothing. And then just hit Alt A, should get rid of them all. Cool. But now we have to do it like this. So namespace Scion rendering. Put that inside there. That looks cleaner to me than having the big long. And here we can go shader program, let's equal to program. Whoops. MS vertex path is equal to vertex path. and ms fragment path is equal to fragment path. Okay, so our constructor is ready. Get rid of this here, get rid of this. So the first one we're going to do is get uniform location. So because we're using an unordered map, we can use an iterator to see if we already have the location in the map. So we can just go auto uniform iter is equal to m uniform location map dot find uniform name. Cool. And then we can go if uniform iter not equal to m uniform location map dot end. So now we just want to see if the iterator is not equal to the end of the map. If it's not, we can just return the iterator's value. The map iterator gives us a key value pair. So the second is the value of the actual location. So by doing it this way, like this, we only have to do the lookup one time for the map. If we don't have the location yet in the map, we're going to have to get the location and then add it to the map. So we go GL uint location equal to GL get uniform location, and that's the shader program ID, and that's uniform name dot cstring. That should give us a location. So let's do a check to see if the location is a valid index. So if location, location is equal to GL invalid index, then we're just going to want to have an error there. So we should create a logger soon instead of always doing this with the cout. So we'll do that in one of the next videos. So right now we'll just include IOStream. So we just want to say that it's not found in the shader. And just return -1 for now. And then if it is, if we get here, we want to add it to the map. So m uniform location map dot in place uniform name and location. And then after all that, we can just return the location. All right. So in the shader destructor, we can just delete the program. Let's just make sure shader program is greater than 0. Sorry, I should say if. Now we just have to do our setters and the enables, not too much. So GL uniform 1i, and that's get uniform location, and just send in the name and value. So we're basically just calling this function up here. It goes, checks to see if it's in the map. If it is, it'll return it, and then if not, it'll add it. And then this one, same idea. So GL uniform matrix for FV get uniform application, name, 1, GL false, because we don't want to transpose, and then the value is of the mat at 0, 0. Awesome. And then for enable, it's pretty straightforward, just GL use program, and that's just our shader ID. And then disable is just GL use program 0. Now we should probably put checks in here as well, and errors if the program is 0, but I don't think it should matter. Okay, so now that we have the shader started, we're going to want to create the shader loader. We could load the shader from itself. However, I like the idea of having a shader loader, texture loader, etc. This will separate the use of the shader from the loading of the shader. So now that we have it ready, let's start the shader loader classes. So go to Essentials, Add, New Item, and we'll call this ShaderLoader.h. And for the shader loader, we're going to need the shader, of course. Shader, and then we're also going to want memory, because we're going to be using a shared pointer. And then we're going to go namespace, Scion rendering, and class ShaderLoader. We'll have some private functions here, and public. Now we want to keep the compiling, linking, and validating functions separate from the public. We only want the create function to be available publicly. So what are we going to have here? So we have our shader loader constructor is just delete. We don't want it to be constructed. And then we'll have static std shared pointer and shader. And we want to create that. And that'll take in a const std string vertex shader path, and then const std string fragment shader path. Okay, and that'll be a reference. And for our private functions, we're going to have static gluint create program, vertex shader, const std string reference fragment shader. Okay, and then we're going to want to compile. Compile shaders. So this will compile one shader, so gluint, and that takes the shader type. And then const std string reference the file path for that shader. That should be a capital L over here. And then we're going to want static bool compile success gluint. That takes in the shader. Then we want static bool is program valid, valid. That takes in the program. And then we want static bool link shaders. That takes in both our shaders and the program. gluint program, gluint vertex shader, and gluint fragment shader. Cool. All right, so let's create all these same way. And then the create function as well. Okay, so first thing I'm going to do is that same thing. remove all these, Control H, replace it with nothing. Okay. There's probably a faster way to do this, I just don't know how to do it yet. Namespace Scion rendering. Cool, that's in there. All right, let's just start at the top. So in create program, first thing we're going to do is go const gl uint program is equal to gl create program, then const gl uint vertex is equal to compile shader. That'll take in the, so we're compiling as a GL vertex shader because that takes in the shader type. Then it also takes in the file path, so vertex shader. And we're going to do the same thing for the fragment shader. Okay, so now if either the fragment shader or the vertex shaders are 0, that means one of them has failed to compile. So we're going to want to not continue from there. So we just go if vertex is equal to 0 or fragment is equal to 0. We're just going to return 0 from here. There's no need to continue. Okay, so now that they've been compiled and it made it here, so it's successful, we're going to want to try to link the shader. So we go if not link shaders, and that takes in the program, that takes in the vertex shader and the fragment shader. So if not, we're going to have to add in IOStream here for now because we don't have our logger. And we're also going to need, since we're up here, we might as well add in fstream because we're going to need that for loading the shader into memory. Okay. So this is just going to be a simple reason. The real reason will be inside of the link shader function. So this will just be on the outside reason. Failed to link shaders. And then we're just going to return 0 again. And then if we make it to here, then we can just return the program. All right. So now the compile shaders function is our meat and potatoes. This is where we'll actually start creating the shader. So let's get into this. So the first thing we're going to want to do is go const gl uint shader ID is equal to gl create shader, and that takes in our shader type. Now we will be loading the shaders from a file, so we'll need to include the fstream that we did already. So we'll need to go std if stream ifs, and that'll take in our file path. Then we want to see if it failed. So if ifs failed, then we just go std cout shader failed to open, and we'll just put the name of the file path. Oops. And just return 0. All right, so if we pass here, that means that we have been able to open it correctly. And we're going to want to read the contents of the shader program using the getLine function. So we'll need two strings. We'll need the content string and the line string. So every line will be read into the contents and will be read in and added into the contents. So we'll make those strings now. So we go std string, and we'll just call this contents. Oops. And then std string line. And then we'll go while std get line ifs line. Let's get rid of this so it's out of the way. We can just go contents plus equals line plus a new line. And then if we reach here, once we're finished, we can close the if stream. Whoops. Then we need to add the contents to the shader source. The shader source takes in a const char pointer, so we need to create that into one. So we need to go const char pointer, and we'll call that the contents pointer, and that is just equal to the contents C string. And then we can add that to GL shader source and a shader ID, and then it takes, so the count just 1, and then our GL const GL char star const star string. Okay, so then it's just this here, our contents pointer, and then null pointer for the length. And now we want to compile the shader. So GL compile shader, and that takes in our shader ID. Now we're going to want to check the compile success here. So we'll just go if not compile success. That's why we created that function. And that just takes in our shader ID. Then we need to go std cout failed to compile shader, and we'll just put what shader file path. And return 0 again. All right, if we made it this far, we can just return the shader ID. Cool. Now we can do the compile success. We're almost done this. So we go GL int status, and we're going to want to query the compile status of the shader. So we go GL get shader IV, and that's the shader that we're sending in, and it's GL compile status. And we're going to send in status. Now we do a little check here to see if it's not true. So if status is not equal to GL true, then we want to check our error. So we need to go GL int max length, or you can put length GL get shader IV. That takes the shader, and we want GL info log length, taking in the length. Then we can use a string here. Now that we have the length, string error log, and you just make it with max length. Put a space, and then here now we want to get it from the log GL get shader info log. That takes in our shader, takes in the max length, also takes in the buff size, which is also max length, and then error log.data. GL. So we can just say shader compilation failed, and then put the reason, std string error log. And this one is return. Oh, first thing we're going to want to do is delete the shader. So if it fails, we want to delete the shader. I should say delete. And we send in our shader. And then just return false. And if it makes it to here, we return true. That means everything was good. Compilation passed. All right, so now there's 3 more. The last one's easy. Then so these 2 is program valid. It's going to be similar to compile shader, or compile success, sorry, that we're just checking the status, but this time we're checking the status of the program. So we can copy all of this. Actually, you know what? We'll just write it all up. So same idea, so GL int status. Now we want to get program IV. Program GL. I'm all over the place. Link status, and then send in our status. And it's the same idea here. Whoops. Now we want to check if our status is not equal to GL true. Then we want to go, we can probably copy these here. We'll copy these and make a quick change. So we get program IV, don't forget that. Get info log length, max length, and this takes in the program. Error. GL get program info log program. Max length, error log dot data, and then std cout shader program shaders failed to link. And then just return false. So we're just getting the error here so we know why. Return false here. If it makes it here, return true. We're almost done. So link shaders is, first thing we want to do is attach the shaders. GL attach shader, not attack shader. Sometimes you feel like attacking them, but, and then we're attaching it to the program, and that's vertex shader and fragment shader. And then now we want to link, so GL link program. Let's change this. Shader program failed to link, GL link program, and that's just the program. So now we want to check to see if the program is valid. If not, we want to delete the program and the shaders. So we created those program, if is program valid function. We're going to use it here, is program valid, send in the program. And if not valid, we want to delete the program and the shaders and then return false. So GL delete program GL delete shader, vertex shader, and the fragment shader. Whoops. And then from there, return false. Okay, so the program has been linked successfully. We can now detach and delete the shaders. So first we want to go to GL, detach shader, program, vertex shader, fragment shader, and then we get these two deletes because we don't need them anymore because it's already been attached and linked. And then we can return true. All right, so now the create function, and we can just go GL uint program is equal to create program, and that takes in our vertex shader path and our fragment shader path. So we want to check to see if the program is greater than 0. So if program, then we want to return std make shared, not make shader, make shared of a shader taking in the program, vertex shader path, and the fragment shader path. Else we return null pointer. All right, now that should work. Let's just try building this. Awesome, build successful. So we need to go to our editor, and we're gonna have to add this as a reference. So add reference, we want rendering, okay. And then we also want to add it to our VC++ directories here. Cool. Oops. Solution, dear, Scion rendering. Okay. Apply. All right, so now that it's added into our editor, we can now go and try to remove all the shader stuff from our main function here. So let's go up here and then just add in our ShaderLoader. So include rendering essentials ShaderLoader. That should have our shader already. And then find our shader stuff and start removing it. So let's get rid of this for now. All this can go, all the status stuff. We'll keep the sources for now. Remove all this. Remove all this shader stuff. Cool. That's all gone. So we'll keep the status stuff here for now because we're going to need to create 2 files because we're going to want to read these files in. So in our assets here, let's create a new folder. So add new folder and we'll call it shaders. So that's in our Scion editor, assets, shaders, and then here we're going to add 2 new files. Add new, and this one's going to be, we'll just call this basic shader.vert. And add, and we'll add another one. New item, basic shader.frag for the fragment shader. Cool. And let's go back into our main, and let's just copy all this. And that's our vertex source, so we're going to put this here, paste it in. Not the best way to do this, but that's all right. And you just got to remove everything that is not needed. We don't need the new lines and the quotations. We get rid of all that stuff. Cool. And this one, let's go back to main, copy this. Same idea. Remove all that extra stuff that's not needed. We don't need this whole line anymore. Cool. So there's our basic shader.frag, basic shader.vert, our loaders, everything, and we can get rid of this. All right, so let's just try to create our shader. Let's say first shader. And we just go auto shader is equal to, not minus, equal to Scion rendering ShaderLoader create, and we put that in our assets slash shaders slash basic shader dot vert, and we can copy this and just change that to basic shader dot frag. And then we just do a check if not shader, because this is a shared pointer. So if we don't have a shader, we can just say std cout fail to create the shader. And then just return -1. All right, so everything down here. So all this stuff here, the use program, we want to change that to shader enable. And the get uniform location, we don't want to do this anymore. We can just, we know it's U projection, so we'll just go shader dot or set map 4, and then we just need the name, and that's this here. And we're just going to send in projection, and we can delete this. Update, and we just go shader disable. All right, that should work. Now let's hit F5 or this button here, and it should go. Yay! So we got our eye going, and we're using the shader loader. Okay, awesome. That's pretty good. All right, so that worked. So in the next video, we'll create the texture class and the texture loader. And for fun, while you wait for the next video, maybe try to create the texture class and loader yourself. So we want it to be in the new Scion rendering project, and it'll also be put into the essentials folder. And what are some things that the texture class is going to need? It's going to need the texture ID, the width, the height of the texture, the string for the texture path. It'd also be good to have some type of texture enum or type of texture that's going to be. So when we're loading, we know how to determine how to create the texture. Maybe make it into an enum, something that we can extend. Okay, give that a shot, and I'll go over how I will be doing it in the next video. Thanks for watching. Please like and subscribe if you haven't already, and I'll see you next time. Take it easy.